We can put them into what is called an X-ray fluorescence analyzer that allows us to infer the composition. And the composition appears to be different than commercial metals that we use here on Earth, anything that humans produce. But it's also different from asteroids, from rocks that previously were analyzed. And that makes, first of all, it implies that perhaps indeed it originated from a completely different environment, and moreover perhaps it was manufactured. Harvard scientists may have just pulled debris from an alien spacecraft off the Pacific Ocean floor. And the fragments, they're tougher than anything NASA has ever catalogued. We're talking about real particles, 850 of them, collected in 2023 from a fireball that the US military says came from outside our solar system. Not theory, not speculation. Actual physical evidence you can hold in your hand. This isn't just another UFO story. It's Harvard astrophysicist Avi Loeb and his team dragging magnets across the seafloor near Papua New Guinea. They were hunting for remains of a meteor that entered our atmosphere at a mind-blowing 45 kilometers per second. Why does that speed matter? Because it's too fast for normal solar system objects. And what they found were tiny metallic spheres with bizarre chemical compositions never seen in Earth samples. But here's the twist. Were these just space rocks? Or could they be fragments of something engineered? The answer could rewrite everything we thought we knew about our place in the universe. Think about it. For decades we've looked for signals in space. But what if the first evidence of another civilization isn't a radio wave, but tiny droplets of metal sitting quietly on the ocean floor? What we're witnessing is a scientific first. No human has ever held confirmed material from beyond our solar system. Every meteorite in every museum came from within our cosmic neighborhood until now. The Galileo Project's expedition off Papua New Guinea marks the first dedicated attempt to recover physical debris from an interstellar object. Harvard's Avi Loeb led a team that spent 2 weeks scouring the Pacific seafloor. Using what they called an interstellar hook, basically a weighted sled with powerful magnets, they vacuumed up hundreds of tiny metallic spherules. These aren't random particles. They were found precisely along the calculated path of a 2014 fireball tracked by military satellites. The most stunning find: about 10% of these spherules are what scientists call Baloo-type particles. Their element ratios are enhanced by factors of 10 to 1,000 times compared to anything we've ever found on Earth, the Moon, or Mars. This is not just dust. Some of these spherules have chemical fingerprints we cannot match to any known natural source. The combination of iron, magnesium, and titanium with almost no nickel stands out as particularly unusual. When you combine this strange chemistry with the object's extraordinary speed and strength, the implications become staggering. If even one of these grains proves to be manufactured, it would be the most profound discovery in human history. But before we jump to conclusions, let's ask, why was the US military watching this fireball so closely in the first place? And what do they know that we don't? This story takes an unexpected turn when you look at who first identified this object. Not civilian scientists, but the United States military. In 2022, U.S. Space Command declassified data about this fireball, officially designated CNOS January 8, 2014 or IM-1. They released a remarkable letter confirming with 99.999% confidence that this object originated from outside our solar system. Think about that number. 99.999%. That's military-grade certainty. But here's where it gets interesting. Why would Space Command declassify this information? And why now? These aren't decisions made lightly in military circles. Consider the strategic implications. A material that's tougher than any known meteorite, something that survived atmospheric entry when it should have disintegrated, could revolutionize aerospace engineering or defense technology. Remember, this object penetrated deeper into our atmosphere than any meteor with similar velocity should have been able to. It survived until about 17 kilometers altitude, displaying material strength exceeding anything in NASA's catalog of 272 space rocks. If confirmed, this wouldn't just be a scientific curiosity. It could trigger a new kind of space race, not for locations but for materials. Imagine alloys or compounds we've never seen before with properties beyond our current engineering capabilities. What do you think? Was this just scientific curiosity or a race for new technology? Drop your thoughts in the comments before we reveal what scientists uncovered in the lab. And stay with us because the lab results shocked even the Harvard team. What they found under the microscope challenged everything we thought we knew about materials from space. When Lowe's team returned to Harvard, they had collected around 850 spherules from the ocean floor. Most were almost perfectly spherical, like tiny ball bearings between 0.1 and 1.3 millimeters across. These weren't just random pebbles. They resembled droplets formed by extreme heat. the kind of temperatures that melt metal instantly. Each one tells the story of a violent moment when something entered our atmosphere and partially vaporized. But here's what makes scientists' jaws drop. These fragments display material strength that exceeds anything in NASA's entire meteorite database. The original objects survive forces that would shatter or vaporize ordinary space rocks. Imagine throwing a laptop into a bonfire. You'd be left with molten blobs of metal and silicon. That's what Harvard scientists are now holding in their hands, only tougher than any known meteor. The chemical composition raises even more questions. While most meteors contain significant nickel alongside iron, these spherules show minimal nickel. Instead, they contain unusual combinations of iron, magnesium, and titanium that don't match known meteorite patterns. This is why some scientists wonder aloud, could these be fragments of alien technology? Now, when we say alien technology, it doesn't mean UFOs flying through the sky. It could mean alloys, designs, or materials we've never seen before. The puzzle is that these droplets are so strong yet so tiny that we can't rule out something extraordinary. What makes this discovery even more compelling is that IM-1 isn't a one-off event. Our solar system has been visited by other interstellar wanderers in recent years. In 2017, astronomers spotted Oumuamua, a cigar-shaped object that zipped through our system at incredible speed. In 2019, we detected Comet Borisov, another visitor from beyond our cosmic neighborhood. But here's what's different about IM-1. It's the only one that may have left physical evidence behind. This raises a profound question. If IM-1 dropped fragments here, how many others have struck Earth unnoticed? Could our oceans already be sprinkled with alien material? The implications are staggering. Earth has existed for 4.5 billion years. Our planet has been bombarded by meteors throughout its history. How many of those came from other star systems? And what might they have brought with them? Houston, we have a problem. I don't think this is Florida. Luckily, I didn't need NASA. I needed a legal army. It turns out there's an injury firm called Morgan & Morgan, America's largest injury law firm with over 1,000 attorneys and more than 100 offices nationwide. I tried calling one of those local lawyers with cheesy jingles. I was on hold longer than a Mars launch delay. Meanwhile, Morgan & Morgan helped a client in Florida get $12 million after the insurance company only offered $350,000. Morgan & Morgan only gets paid if they win your case. No upfront fees. You can file a claim right from your couch or from the jungle. Here's how easy it is. You can just click the link in the description or scan the QR code on screen. If you're ever injured, you can check out Morgan & Morgan. Their fee is free unless they win. You can start your claim by clicking the link below or scanning the QR code on screen. Music. Some scientists suggest that interstellar debris might even carry the seeds of life itself. This concept called panspermia proposes that biological building blocks could travel between star systems. Imagine the wonder of discovering that life on Earth began with molecules delivered from another solar system. Our very existence could be connected to distant stars in ways we've never understood. But what makes IM-1's droplets so puzzling is that they don't match Earth, Mars, or any known asteroid. And that's where things get really strange. When scientists analyzed these spherules in the lab, they found chemical signatures unlike anything in our cosmic neighborhood. It's as if someone handed you a metal that doesn't appear on the periodic table. To understand the potential significance of these tiny spherules, we need to look at similar watershed moments in science. In the 1980s, scientists discovered microscopic glass beads in a thin layer of sediment worldwide. These Chicks love impact spherules eventually helped prove that an asteroid killed the dinosaurs. Tiny balls of material rewrote our planet's history. Or consider the first lunar meteorites identified in Antarctica in the 1970s. Before Apollo brought back moon rocks, these unassuming stones were our only physical connection to another world. The IM-1 spherules could represent one of those rare moments in history when science takes a dramatic leap forward. We're potentially witnessing a turning point in our understanding of the cosmos. What makes this moment so breathtaking is the possibility that we're handling material from beyond our solar system for the first time. Objects that formed around another star, traveled interstellar space for millions of years, and ended up in our hands. 50 years from now, textbooks might look back at these droplets the way we now look at the first moon rocks. The beginning of a new chapter in astronomy where we don't just observe distant stars, we touch pieces of their worlds. Here's the thing. Right now, these are just tiny beads in a Harvard lab. But if they prove interstellar, they'd be humanity's first physical package delivered from another star. And that would transform our relationship with the cosmos. We would no longer be isolated observers. We would be handling messages in a bottle from the stars themselves. The story doesn't end with these microscopic spherules. In fact, it's just beginning. Avibe and his team are planning something even more ambitious for 2025. They intend to send an underwater robot, the ROV Hercules, back to the exact same location in the Pacific. Their goal to find larger fragments of the original object. Think about what this means. The sparables they've collected so far are essentially molten droplets like splatter from a cosmic collision. But somewhere on that ocean floor, there could be chunks of the actual object itself. A piece large enough would transform our understanding. Scientists could radiometrically date it to determine its age. They could analyze its isotopic composition, the fingerprint that reveals where in the galaxy it formed. Most tantalizing of all, they could examine its internal structure. As Lowe himself notes, imagine throwing a laptop into a fireplace. By retrieving the residual molten droplets, it would be impossible to conclude whether the original object was artificial. But a larger fragment might preserve structural features, layers, patterns, or compositions that couldn't form naturally. If confirmed, this would mean for the first time in human history, we're studying matter from another star system right here on Earth. Not just light that traveled across space, but actual physical material we can touch and test. The implications would stretch far beyond astronomy. We could learn about the chemistry of distant planetary systems. We might discover alloys or compounds previously unknown to science. And if even a hint of artificial origin emerges, it would change everything from technology to how we see ourselves in the universe. Imagine if this really is the first sign of alien engineering. What would that mean for our future? Would we reverse engineer new technologies? Would it spark a new space race to find more interstellar objects? Now that we've explored the implications, let's look at how this extraordinary story began. It all started on January 8, 2014. U.S. military satellites detected an unusual fireball streaking through the atmosphere near Papua New Guinea. Nothing about this event seemed ordinary. First, there was its velocity. Approximately 45 kilometers per second. That's far faster than almost any meteor in our solar system. Most asteroids hit Earth at speeds between 11 and 25 kilometers per second. Then there was its trajectory. After careful analysis, government scientists determined it was on an interstellar path before it ever reached our solar system. Most surprising was its strength. Despite its tremendous speed, this object survived until it reached about 17 kilometers altitude. Normal meteors would have disintegrated much higher in the atmosphere. For years, this event remained just another data point in government records. But in 2019, Harvard astronomer Al Loeb decided to investigate further. He assembled a team for the Galileo Project, a scientific initiative specifically designed to search for evidence of extraterrestrial technology. In June 2023, they set sail on the Silver Star toward a spot about 84 kilometers north of Manus Island. For 2 weeks, they dragged their magnetic sled across the ocean floor, hunting for fragments. Only now, nearly a decade later, are we holding its fragments. These tiny spirals traveled across interstellar space, burned through our atmosphere, and settled on the ocean floor, only to end up in Harvard's laboratories. Where does this leave us? The science is still unfolding. The spherules might prove natural. They might prove interstellar. Or just possibly, they might prove engineered. What we know for certain is that they're unusual. Their chemical composition differs from typical meteorites. Their strength exceeds what we'd expect from normal space rocks, and they came from an object moving faster than typical solar system debris. Skeptical scientists raise valid concerns. Could these be industrial pollution, coal ash, volcanic particles? These questions deserve rigorous investigation. That's why the isotope analysis underway right now is so crucial. It could reveal whether these particles formed around our sun or a distant star.